In this next section, we're going to be talking about geometric sequences and series. A geometric sequence can be defined recursively. A sub 1 is going to represent our first term, and our common ratio is going to be defined by the letter r. R in this case could not be equal to 0. And when we're looking at the recursive formulas here, you might see it written two different ways. This first one, we have a sub n equals r times a sub n minus 1. Or you can see it written so that you're dividing out these two terms, a sub n and a sub n minus 1. And when we divide those two terms out, we're going to get our common ratio. The terms in our geometric sequence are going to follow this general pattern. We're going to have a sub 1, which is our first term, a sub 1 times our common ratio for the second term. For the third term, we'll have a sub 1 times that common ratio squared, etc. Let's go ahead and take a look at this sequence of numbers. We have 3, 12, 48, 192, 768, etc. Our first term, a sub 1, is the number 3. Let's see if we can calculate our common ratio. Keep in mind, when we're finding that common ratio, we want to go ahead and divide out two successive terms. It doesn't matter which pair you decide to find that ratio of. For example, I can take my second term and divide it by my first term, and that's going to give me a common ratio of 4. You could have been the person who decided to divide your third term and your second term. That would have still given you a common ratio of 4. This is an example of a geometric sequence, and the ratio of our successive terms in this case is 4.